Perfect. So, does anybody know what this date is? August 2nd, 2023. So this is the date for 2023 that was World Overshoot Day. This marks as the date when we had used all the biological resources that the Earth is manageable to regenerate in 1 year. And World Overshoot Day is calculated, or Overshoot Day is calculated by this formula. So we take the 365 days per year, and you divide the ecological footprint of a country with the global biocapacity, and both per person. And from that, you get the individual date for one country. And then all of these are added together, and you get the World Overshoot Day. So in Sweden, where I come from, World Overshoot Day, or Sweden's Overshoot Day, has already passed. That was April 3rd, 2023. And this means that if the world would consume the way that we do in Sweden, we would have used all the biological resources that the Earth can regenerate in 1 year already back in April. Can anyone guess the date for Pakistan, where Sajid comes from? So Pakistan, there is no Overshoot Day. As we all know, we have huge inequalities in the world, and the way that we consume in the West is having environmental impacts in other parts of the world. But we're not going to talk about this today. We're going to talk about how we as developers and builders can contribute to a lower CO2 usage by architecting for sustainability. My name is Björn Eriksen, and this is
Mohammed Sajid.
And we both work in the Solutions Architect team at AWS here in Stockholm. So the trend has been clear since 1971. We've gone from consuming 1 Earth per year to consuming 1.75 Earths in 2022. Today we're going to talk about what you as an API publisher can start doing today to make more environmental friendly choices in your design and implementation. But let's be honest, we're not going to change the world by changing API design. The only way we can have real impact is by changing the way that we consume. Also in API, or within APIs, we have publishers and we have consumers. And there is a shared responsibility between the two. But if the publisher of an API doesn't give the consumers a lever to use for how to lower the CO2 impact, this shared responsibility more becomes a wall of separation. I'm going to give you an analogy that we're going to use throughout this talk. In EU, road transport accounts for about 1/5 of all the CO2 emissions, and passenger cars are a major polluter. They account for 61% of the CO2 emissions in EU road transports. And when you use a car, when you're driving a car, you sometimes need access to the full power of the engine. But at other times, speed and response time is not your highest priority, and you can enter into eco mode in your car. Eco mode is a way for you as the driver or the consumer of the car or the producer to tell the car that at this time it's not the highest, you're okay with lower performance, and thereby lower use of resources. And to take this analogy even further, you have the same feature in a dishwasher, where you as a consumer can choose an eco mode, and the program will take longer time to finish, it will use colder water, but the end result will be the same. But the question is, does your API have an eco mode?
Thank you very much, Björn. How many of you, raise your hands, how many of you are responsible for sustainability and environmentally friendly software development at your company? Okay, at this question, every one of you should raise your hands, because this is the shared responsibility. This is every one of us should be taking care of the sustainability and eco-friendliness of our software that we develop. So it's pretty simple, like IT is the part of the problem. Why IT is the part of the problem? Because most of the energy is produced by fossil fuels these days, and obviously when we are working with software, when we are developing software, or whenever we are running something, be it in a local infrastructure or in cloud, basically we are using energy. So energy we are going to use as a proxy matrix today to understand how how can we produce a software that is much better, much more friendly to the environment. So in this short session, you will know a little bit more about the carbon efficient software. So we will be using certain formula there as well. And what is like software carbon intensity, how you can measure a software carbon intensity. And here software, I mean APIs, obviously, because API is a kind of a software. And as already Björn mentioned, we will talk about a little bit about eco mode, how you can actually implement it in your APIs. There is a very simple mechanism or way that we have like identified one way to implement it. And obviously, we will not let you go without giving you like tons of links and learning resources that probably you will never read. Anyway, so most of you probably are aware of it. Like back in 2021, web traffic exceeded 2.8 zettabytes. How many of you can tell how much is zettabytes actually? Raise your hands. I didn't know. So in 2.8 zettabytes, you can store 21 trillion MP3 songs. And obviously, we have to be alive for 119 million years to listen to all these songs. So imagine how big data it is. And 83% of that traffic was going through APIs. So API account for like a lot of web traffic these days. So that means whatever optimization that we are going to do with the APIs, that will directly impact on the overall software sustainability. So there are three ways. So what is the goal? There are three basically goals for us. We reduce the carbon emissions, right? We use electricity as a proxy metrics for carbon. And how do we measure? We measure it in the grams CO2 equivalent, or EQ is equivalent, because that's not, CO2 is not the only gas that is responsible for the greenhouse. CO2 is not the only greenhouse gas, right? So these are the three things. But how do we reduce carbon emissions in a software? I mean, as I mentioned, we have to look at electricity. So the more energy we use, the more carbon emissions our software will be doing. So what is a carbon efficient software? Obviously, green software is a carbon efficient software, but how we can make it more carbon efficient? So in a simplest way, we have to reduce the energy consumption of our APIs. The lower the energy consumption is, better the software is, right? So there are three ways we can do that, right? Energy efficiency, carbon awareness, and hardware efficiency. And I will let's look at these three. So energy efficiency means we will be using least amount of energy to solve a problem, to run the software. Very simple. And carbon awareness means we will be running bigger workload or doing a lot of work when energy is cleaner as compared to when energy is a little bit dirty. What does it mean? It means, let's say, if you have lesser load during the night, probably you will be doing a lot of processing during the night time, right? Rather than doing everything during the daytime when you have a lot of requests and requesters coming and your energy prices are higher, probably you're using more fossil fuel-based energy as compared to the green energy. So you have to understand that part. But how we can control this thing? By using infrastructure, or a lot of cloud vendors also have like this green energy. Their data centers are running on quite green sources. So we can choose public cloud providers as well. The last one is hardware efficiency. This is like, this talks about the embedded or embodied carbon. That means how much carbon has been emitted while producing a hardware. That is the third thing that we have to think about. So if we do not own a server, let's say, if we are running in a cloud vendor, probably that's what the cloud provider will tell us, like how much embedded carbon is included in this hardware. But let's talk about the mobile phones or any other hardware like a laptop that we are using. So we have to make sure we do not get rid of a laptop or a mobile phone in a very short period of time. We want to make sure we use it for its entire lifetime, okay? But what's the problem with the software? I mean, especially for the firmware, I mean, these devices get obsolete very fast when we have new requirement from the software. So when we are building APIs, we need to make sure we actually build them in a way so that those APIs can run on legacy hardware as well. That's how we will increase the lifespan of the hardware. And first of the most important thing is, where do you run your APIs? When you develop an API, right, you're a publisher, how much thinking you do for deploying your API, like where you are running? So most of the time we are looking at, okay, where my customers are coming from, right? where are all these consumers? But we do not think about, okay, the sustainability perspective, we do not look much in that case. So we have to think about, we have to use the energy efficient region. So you can actually identify which locations have more energy efficient hardware available. For example, this screenshot I have grabbed a few weeks back from this electricitymaps.com. And here you can see like the green area is more energy efficient area, and other colors are a little bit less energy efficient area. So you try to deploy your software, to try to deploy your APIs, or use the cloud regions located in these green areas. And you can see there are very few green areas, unfortunately. So at least you can try your best. And again, based on the time, you can use most of your workload, run most of your workloads in the green area. Now, how do you make sure you run these workloads or process these requests at the time when energy is clean? So you implement some kind of an architecture pattern that can help you do that. For example, if you look at this simple architecture pattern where you are doing queue-based load leveling, this is a classic, one of the very classic backend architecture where you basically decouple your systems, right? But here, what you can do, you can implement queue-based load leveling, like have a queue and process the low priority messages later on when the energy is more green. Okay, I'll give you an example. How many of you have done shopping from Amazon? I'm looking at who has not done. So, how important it is to receive the email confirmation immediately versus after 5 minutes. I mean, most of us, we don't care. As long as we have order confirmation on the internet, we don't care when we will receive the email receive the receipt in an email after 5 minutes or 10 minutes or 2 minutes. We don't care much about it, right? As long as our order has been accepted. So that's how you can process certain messages later on, right? At the time when energy is clean, when the load is a little bit low on the system, as compared to doing everything immediately. Similarly, a very good pattern is the event-driven pattern, and we can use it in our APIs that can also reduce the energy consumption with the help of, like, we can use tools. It does not matter, it doesn't have to be in AWS, but in any cloud or even in your on-premises infrastructure, you can actually build event-driven systems, and event-driven systems are usually more energy efficient, right? Because you're doing asynchronous processing, and you're not locking the CPU, and you are doing so many things together in most of the cases, especially if you implement it in a good way. What about the legacy systems? Okay, raise your hand who does not have any legacy system in their company. This is where I'm trying to find out who raises the hand, right? So we all of us have to sometimes deal with some kind of a legacy system, right? And legacy systems, in most cases, are not very carbon efficient. They are using more energy, they have strict requirement about the hardware, and also, in most cases, they are not event-driven. They are mostly using a request-response pattern with the APIs or using a lot of CPU cycles. So how do we do that? I mean, rather than like contaminating the entire system because of that one legacy system, what you can do, you can isolate these less energy efficient system into behind an anti-corruption layer, and then you can use other services for event-driven. All right, but what about eco mode? How we can implement? I told you, I mean, there is a very simple way that we are right now exploring how we can implement it. What about putting a HTTP header or some option for the API publisher to understand whether you want to use echo mode or you want to use the non-echo mode for your API call? And here the idea is give this control to your developers. Give this control to your API consumers. Rather than we decide everything, right? Your developer or your consumer of your API will decide they want to go for this eco mode option or not. All right? In some cases, they do not want to go for the eco mode option. What do? Why don't you make everything eco mode? If you make everything eco mode, obviously you're not giving this control to the consumer. Here we want to give this control to the consumer so that if they are using non-eco mode option, probably they will be charged a little bit more based on their calls. When they are using eco mode option, we can give them something for cheaper. It's the same concept a lot of cloud providers also use, like spot instances where You don't care about the interruption. You don't care about the time of processing certain things. As long as you use eco mode, your call will be much cheaper in terms of energy, and you will not be charged quite a high money for this. Does it make sense? So how we can actually, behind the scene, at the back end, how we can process that eco mode? I mean, we can have two different queues. You might have heard about the priority queue concept. Here you can have a green queue or eco-friendly queue here. So if your API receives a request which has eco mode on, probably you will put it into a queue that is running in a more energy efficient data center, right? And there you do not have a requirement of processing it immediately. There you can process this message in your own time, maybe during the night time when you have a very low load on your system. And also you can process this in a region where energy is green, right? You might have some constraint about the data cannot leave certain regions and all that. So still you should give this choice to the developer or consumer of your API rather than deciding everything yourself. Right, so obviously this pattern can be implemented in so many different ways. So you can have this pub sub or topic-based, subscription-based mechanism to process your messages based on the requirement. So, but how do we measure it? I mean, as Peter Drucker said, if you can't measure it, you can't improve it, right? When you measure something, it gets improved. When you measure something and report it back, it improves exponentially. So it is very important to measure when you really want to improve something. So how we can measure, as I mentioned in the beginning, we will talk a little bit about software carbon intensity. Intensity is a big topic, so we cannot obviously cover everything in this short session. So this is just like giving you a flavor about software carbon intensity. So SCI, what is it? Let's see what involves in calculating the software carbon intensity. So we just need to know the RIME, R-I-M-E, of an API. So what is RIME basically? Let's look at it. So E is the energy consumed by software or API in this case, and we are obviously measuring it in kilowatt hours. Then we have I, which is carbon emitted per kilowatt hours of energy, and M is this embedded or embodied carbon. That means the carbon that was used or that was emitted during the creation of the hardware. And the R is very important. This is the functional unit or the unit of work, basically. That's how you are measuring it. And unit of scale means this could be, let's say, per 100 requests or per 1,000 requests or per 1 million users or whatever way. This is what you will define as a publisher. So another idea is, by the way, software carbon intensity, you have to measure it, and it's a rate of basically carbon emission. You can also calculate it in different ways and give it back to your consumer almost for each call. So when they request, if the eco mode is on, in the response, you might have another response header or some other way you can actually tell your consumer how much carbon emission roughly this request did for you in that case. So if you're running your software in cloud, there are obviously a lot of different vendors, a lot of APIs that you can use to generate this or get this information about this embedded carbon and also how much certain regions are costing. So you can use this kind of APIs. And I'm sure there are a lot more APIs like these, but this is the one just for the example. All right, as I mentioned, I cannot leave you without giving a lot of things to read. So if you want to take a picture, please feel free to take this picture so that you can learn about this software carbon intensity, because everything is coming from this green software practices that you can learn later on in your own time. All right, so in the end, I would say we do not inherit the earth from our ancestors. We borrow it from our children. So we really need to be careful when we are developing APIs, when we are developing software. How many of you are responsible for sustainability in your company? Thank you very much. It was great presenting in front of you.
Thank you.